All right, so the fundamental theorem of calculus is something you've already done. We're just going to formalize the theorem, okay? Because it's a big part of math that you have to know. Once you get at this level, you start to work on not just using the calculations, but knowing why they actually work, okay? So you have already done problems like this, right? So what's the antiderivative?
3x4.
Okay. From? Right, which, and then we evaluate right? Okay. So you know derivatives and antiderivatives. All the fundamental theorem of calculus does is connect the two of them. Okay. So basically, what we're going to do is say that this function, right? This we're going to call big f of x. Okay, so we'll say that big f of x is the antiderivative of little f of x. Is that a correct assumption? Okay. Evaluate it. Let's call this just a and b. Okay, am I tracking so far? So you've got a function and the antiderivative from a to b, right? This is generalizing, okay? And then if we evaluate, we have big F at b minus big F at a, right? You okay with that?
Yep.
That's the fundamental theorem of calculus.
Thank you.
Okay. So basically, if we write it out formally, we'll always just write that. It's the Federal Trade Commission. Right. The liberals worth sending me right now. Assume that. So we always have the assumption in a theorem, right? F of x is continuous. Okay, so we have to have a continuous function to do an integral, and then we have some interval a to b, right? So that's always a part of a theorem. What was the assumption for intermediate value? So, yeah, so if we're looking at theorems that we know, the IVT has an assumption that we are just continuous. Okay, yeah, mean value theorem. Okay. So, and then we could also extreme value theorem that only need continuity, right? So that's the FTC. Most see how all of them involve continuity, why it's so important. Okay.
So most of the time on the test, will it tell us, assume that it is or is not continuous, or will we have to figure that out ourselves?
Most of the time, you will be, it will state, okay, if it's a table or something that's not a function like this, right, that you can get that function, you know it's continuous and differentiable. Right? You can make that statement. But if it's a table or something that's a graph, you will, most of the time it will say f is continuous and twice differentiable or something like that. Okay, so f of x is an antiderivative of x, okay, which we put up there, right? That's all that's saying. On AB, don't forget, we're gonna be perfect here.
Oh.
AP does not say it like this. Okay. AP will say this. Are those statements equivalent?
Yes.
Yeah. If this f of x is the antiderivative, that means if I derive it, I get f of x, right? Because we can go backwards. F prime of x gives us the original. So this is how you'll see it most of the time on the AP stuff. This is how our book likes to say it. So get used to it. But if you ever see that, it's like, oh, fundamental theorem of calculus. It's like alarm bells, right? And then what we say is the same thing we said above. Without the middle in it. Okay, that's the actual statement of the fundamental theorem of calculus.
This is just learning how to put it in letters rather than...
Yeah, you're just generalizing it. So instead of a specific problem, this is the statement in mathematics that allows you to calculate all those. It just says it's okay. And then the problems that you're going to see are problems that you've already been working on. Okay. For now, we will, of course, throw a few things in there here and there that I'll teach along the way today. And we'll show you some more tomorrow. Do you want me to show you a couple more of those definite integrals?
Is this on caution? Homework?
Should be. I think I updated it. Okay. So, how many ways? Okay. Here's an example. Calculate. Okay. I can say calculate that integral, right?
Yeah.
Okay. How else can I make that statement? What else? What does that mean? What are we doing? Okay.
We're evaluating a big fx from 2 to 4.
If I calculate this numeric value, what does that have? What have I just calculated?
Area.
Okay, so you could also say calculate the area between the curve and the x-axis of f of x equals x cubed on 2, 4.
Yeah.
Okay, that's another way to say the same thing, right? So get used to seeing that. Is there any other way to say that? I can't think of it right now, which probably is.
Can you say like range with the fundamental theorem?
Yeah, that's pretty much the two main ones.
Big
Okay, so you, and now you just go calculate it, right? So what's the antiderivative?
X to the 4th over the 4th.
Evaluated from,
2 to the 1.
all right, and then plug it in, right?
If you do the same thing here that we did as a homework problem, it can become 4 cubed.
Yeah, this is 4 cubed, right?
Yeah.
So 64 minus
4.
4 is 60. So we have just use the fundamental theorem of calculus. We don't have to say that or anything, it's just that it's what we've done. Okay. Oh, here's another way they'll say it. Oh, that's not the graph. That's dummy. Not you, me. Because I should know that explicitly. Okay. They will say from 2 to 4, and they'll call that R.
R?
Yeah. And this will be f of x equals x cubed, right? Calculate the area
R.
of region R. That's another way that you'll see it. This is the AP way. Like if you see this kind of thing on the free responses, this is how it's stated a lot of times.
Will they,
Okay.
would it be f prime of x equals x
No.
equals 3? No?
You mean this?
Yeah.
No, they will give you the graph with these points,
So then you would just,
and it would say calculate the region R,
so then just
and this
do-
is the original function.
So if you see that, you just always do the antiderivative?
Yeah, well, that's exactly what you have here is a direct math question, like calculate this value, versus you have to know what area under a curve is, and then you have to calculate it. Right. Same problem. All three of these
Right.
questions are the same thing. Okay, so
Just in the third one, they expect you to know that that is.
yeah, we expect you to know how to calculate the value and the meaning behind it, and be able to use it both ways. Right? Let's do a harder one. Okay. Why is this harder?
Fraction.
I hate fractions. No, I don't. I love them. They're
No, you
very, very lovely.
don't lie to us.
Never mind.
Stop lying to everyone, including yourself.
Fractions are our friends.
No, they're food.
You're lying.
Fish are friends, not food.
Yeah, that is a label. Fractions are not friends.
All right.
They are
When they
food.
have 10% cheaper than a
Okay, what's the antiderivative?
Something evil?
X to the
Negative 7
Pain.
No, add 1.
X to the
Oh, add
fourth.
one.
I don't know.
To the
To the 1/4.
X to
1/4,
the
right?
Over
Because you
4.
add 4 over 4.
X over.
Over 1.
Oh, Lord.
So 4x to the 1/4.
X to the 1/4.
It's 4x to the 1/4. Yes. Okay.
Oh, I got a good one.
All right. Next one.
Oh.
3x to the 8/3 over 8/3.
Yeah, so add 3 over 3, right? So that's 1. All right. It's a lot better if you do rewrite those nasty fractions.
So 9x 3/8 over.
This is 4x to the 1/4 and 9x to the 3/3 over 8.
Wait,
What?
I'm just gonna work this
Okay.
out in my brain.
That's fine. Remember, fraction division. Copy dot flip. Flip it, it becomes 4. Flip it, it becomes 3/8. Multiply. Copy dot flip.
Okay, that makes sense.
And then evaluate. What?
Can you, this, you probably actually don't think this because it's still puppy dog, but
That's what he admits it.
take the 1/4 and multiply it by the 4 and just make that x plus 9x to the 8/3 over 8. Because whether or not
What?
you plug, you see when you plug 3 and 1 into there, you just get 3 and 1 again.
How? What?
So
I
can't you just make
think-
that x plus 9x
I think
to
you're
the
wrong.
8/3 over 8? I mean, it might kill puppies, but
What's
is
the
why he
fourth
admits
root
killing
of,
puppies.
what's the fourth root of 3?
Yeah, you can't pull that 3 out. Is that what you're trying to do?
no, I'm not trying to pull the 3 out. So when you calculate that, you'll get 12 and 1.
No, you do not get 12.
Is 3.
You don't get
Yeah, 'cause-
No.
Oh.
PEMDAS. Let's go back to 5th grade for a
That's
second.
not.
It wasn't
Let's do our exponents first for order of operations and then multiply.
Fourth root of
A 4th root of 3.
of
Yeah, so this is a nasty decimal, right? Nasty decimal. We're gonna have
And we
to.
just leave it like that 'cause that's the numeric answer.
Wait,
No, in class you need to get the answer, so this is where I would calculator it.
why is that? Wouldn't that be like the square root? Because 4.
Here's what's nice about this problem. That's 4, and that's 9/8.
Yeah.
Okay, so that's easier, but these are nasty decimals,
Okay,
so
so
just use your calculators.
5.264 plus 3 to the 3rd. 21.060.
Okay, and then finish it. Okay, we're good?
That's 21, yeah.
060, yeah.
Oh, that's 9 over 8, not 5 over 8. I just looked at that wrong.
Can we just leave it as this?
No, finish it. That's in class, we always finish.
31.449.
For the whole thing?
Yeah. Oh, we should factor that in.
Yeah, no, I was gonna say no.
Yeah, he asked that.
I did.
Hey. Don't make me make my whiteboard a blackboard.
Sorry, 29.199. My bad.
Any objections?
Yes. What do you get for the? Because 21.060 plus 5.264 is going to be 26. If you take 26 minus something, it can't be a greater number.
Take that, Damon.
Oh, good. Still take the same number.
You're so negative. So
No, 'cause it's nice.
I got negative 20.42.
Well, the answer is 21.
Well, obviously he has to have those numbers right. And it looks pretty darn close, to be honest with you. I bet that's correct. This is out of the book, okay? It's right.
We found errors in the book before.
21.2. Okay.
Does that say
We found
prelim
errors
1?
before.
Yeah.
Is that prelim 1?
Yeah, so 5.3 prelim 1A. Yeah, do prelim 1A.
Hey,
Here we
I'm
go.
Canadian, eh?
That's so funny. And then your exercises and your spiraling.
He's so proud of him.
I'm very proud of myself.
For making a Canadian joke?
Whoa, that's a lot more than I was on your sheet.
Oh, did you? Okay.
Shouldn't be. Right here.
That was all one day?
Stupid Tuesday and not.
What is FTC one?
Fundamental theorem of calculus, part 1. Means we have tomorrow more work in part 1, and then Tuesday and Wednesday of next week we're going to do part 2.
So is there an FTC two?
Okay, so do Tuesday. Again, a lot more practice on calculating integrals, and then spiral. Thanks for playing.
Spiral tonight.